Determine the value of each logarithm without a calculator. Part A, log base 8 of 32. So, we'll begin by rewriting this logarithm in its exponential form. In other words, we'll say we don't know what this logarithm is equal to. I'll call it x. So this logarithm rewritten really is the same as 8 raised to the x power is 32. Or in other words, what power of 8 will give us 32? And if you think of your powers of 8, you'd think 8 to the first power is 8, 8 to the second power is 64, and so on. And you might think, well, 32 is not on that list. But if we do some creative algebra, we can get the bases here to be the same. So we want the bases to be the same on the left and the right. So if we choose a base of 2, we realize that 8 is a power of 2, and so is 32. So 8 is equivalent to 2 cubed. So we'll rewrite 8 as 2 cubed. And 32 is equivalent to 2 to the 5th power. So remember, when we have a power raised to a power, that means we'll multiply our exponents. So 3 times x is the same as 3x. So now 2 to the 3x power equals 2 to the 5th power. And now, since our bases are the same, we know that the exponents will be equal. That's the uniqueness property. So then we can say that 3x is equal to 5, therefore x is equal to 5/3. So back to the beginning, log base 8 of 32 is the same as 5/3, or it is equivalent to 5/3. So 5/3 would be my exact answer, the value of this logarithm. Part B is log base 2.5 of 125 divided by 8. So again, I'll say I don't know what this logarithm is equal to, log base 2.5 of 125 divided by 8, so I'll just equal it to x, some unknown. And rewriting this in exponential form, we realize this is the same as 2.5 raised to the x power is equal to 125 divided by 8. So you'll notice you have a decimal on the left and a fraction on the right. So it'd be easier if either they were both decimals or both fractions. And since I'm trying to do this without my calculator, it's actually going to be easier for us, if you convert your 2.5 to its fraction form. So I'm going to rewrite that as 5 halves. So we have 5 halves to the x power is equal to 125 divided by 8. And now we want to try to get the same base, the base on the left to match the base on the right. Well, if you notice, 125 is really 5 cubed. 8 is also 2 cubed. So we can actually rewrite 125 over 8 as 5 halves, the quantity cubed. So now we have the same base on the left and the right, therefore x must equal 3. So the value of my original logarithm is 3. Part C, the natural log of e times the square root of e. So, a couple ways of attacking this problem. One way, again, is to realize that natural log is the same as log base e. So a natural log is a logarithm with a base of e. So my argument now is e times the square root of e. So again, if we don't know what this equals, we'll just say it equals x, and you can rewrite this in exponential form. That'll give us base e raised to the x power is equal to e times the square root of e. And then you can do a little bit of manipulation on the right-hand side. We have e, which is really e to the first power, times the square root of e, which would be e to the 1/2 power. And we know that our product rule says we add our exponents in this case. So 1 plus 1/2 will give us e raised to the 1.5, or in other words, 3/2 power. So now we have e to the x is equal to e to the 3/2 power. Bases are the same, therefore we know the exponents must be equal. So x is equal to 3/2. So this logarithm is equivalent to 3/2. Now, that's not the only way to tackle this problem, so let me just mention, if you know your properties of logs, you could also utilize your properties in this case. So if you realize that we have an argument here, e times the square root of e, and my argument contains multiplication, then I could use my product property for logarithms that allows me to rewrite this as the sum of two logarithms. So it would be the natural log of e plus the natural log of the square root of e. And then I know that the natural log of e is going to be just 1. And if I do some rewriting here, the natural log of the square root of e, well, square root of e is really e to the 1/2 power. Therefore, the natural log of e to the 1/2 is just 1/2. So we end up with 1 plus 1/2, and that's another way of getting your answer of 3/2. Part D, log base 27 of 1/81. So I don't know what this logarithm is equal to. I'll just say it equals x. Rewrite this in exponential form, and we realize we have 27 raised to the power of x is equal to 1/81. In other words, what power of 27 will give me 1/81? So we'll try to get the bases to be the same on the left and the right. And if you realize that both 27 and 81 are powers of 3, then we can rewrite this as base 3. So 27 is the same as 3 cubed, and then that's still raised to the x power. And I'll do the right-hand side in 2 steps. I'll start with just the denominator. 81 is really 3 to the 4th power, and then 1/3 to the 4th power is equivalent to 3 to the -4th power. And on the left-hand side, we have a power raised to a power, so we know we will multiply those exponents. So this would be 3 raised to the 3 times x power, or just 3x power. And now that my bases are the same, I know my exponents will be equal, and that's the uniqueness property again. So 3x equals -4, x is equal to -4/3. So the value of this logarithm is -4/3. Part E, log base 0.2 of 25. So I don't know what power of 0.2 will give me 25. So I'll set it equal to x, rewrite in exponential form, 0.2 raised to the x power is equal to 25. And once again, this is a case where I think it'll be easier for you to deal with fractions rather than decimals. So I'll convert my decimal. I know that 0.2 is really 2/10. So we have 2/10 to the x power is equal to 25. But 2/10 could simplify to 1/5. And by simplifying it to 1/5, hopefully you can start to see that I'm going to be able to use a base of 5. I can rewrite the left and the right with a base of 5. So on the left, I have 1/5, which is equivalent to 5 to the -1st power, 5 to the -1, still raised to the x. And then on the right-hand side, I have 25, which is the same as 5 squared. So multiplying my exponents, I have 5 raised to the -x power is equal to 5 to the 2nd power. Bases are the same, therefore uniqueness property says exponents must be equal. -x equals 2, so dividing by your negative gives us that x is equal to -2. So the value of this original logarithm, log base 0.2 of 25, is -2. And finally, part F, log base square root of 3 of 3 times the square root of 3. So once again, I'll start with my rewrite. So I don't know what this logarithm is equal to. Call it x. If I rewrite it, I have the square root of 3 raised to the unknown x power is equal to 3 times the square root of 3. And my goal is to get the bases to be the same. So the base on the left is the square root of 3. So we'll see if I can manipulate the right-hand side so that it will also be a base of square root of 3. Well, I know I have 3 to the first power times the square root of 3, which is 3 to the 1/2 power. So if I add my exponents, 1 plus 1/2 will give me a new exponent of 3/2. So now I have the square root of 3 raised to the x power is equal to 3 to the 3/2 power. But it helps to remember that when you have a fraction exponent, so this exponent of 3 over 2, when you have a fraction exponent, you can really turn this into a radical. So if we look at it in radical form, the denominator of that fractional exponent tells me that my index is a 2. In other words, it's a square root, the square root of 3. And then the numerator tells me that is my new exponent, so this would be cubed. So 3 to the 3/2 power is the same as the square root of 3 cubed. Therefore, let me clean this up so this looks a little cleaner for you. Square root of 3 to the x is equal to the square root of 3 cubed. We actually have the same base now. Left side, right side, both are bases of square root of 3. Therefore, exponents must be equal. X must be 3. So the value of this logarithm is just 3.